To be honest, this is the point when the build becomes so challenging it's almost more stressful than enjoyable.
Did I get the spelling right?
But as they say, the customer is king. So this being probably the most difficult and complicated bass build I've ever done, I want to show you the process more from the technical perspective. I had to learn tons of new stuff and step into a basically experimental zone.
Bear with me, all of this is absolutely necessary.
As always, I started the project by making a laminated neck blank which will go through the body. This time I'm gluing together curly maple and ash, and I decided that I'll be sketching these cross sections so you can understand what's going on. So far it's pretty straightforward, but things will escalate quickly. I routed channels for the carbon rods and a truss rod, which I would normally have sitting there just flush with the surface of the blank, but in the case of this build, I need all the neck reinforcements to be recessed a bit deeper, because I'll be covering the rods with a 2.5mm thick strip of maple. And what's the point? You'll see later.
So far so good. The maple strip was surface flush to the neckband. And now, let's do the fretboards. And the first step will be routing the band logo on the top of the fretboard. This will be probably the most stressful part of this build.
That's right, the customer is the bass player of Czech death metal band Dysangelium. And he wanted me to do the band logo inlay in the middle of the fretboard. And because I still don't own a CNC machine, I had to do this by hand with my Dremel holder and these thin carbide bits, which are meant for CNC, but now you will see why they call me human CNC. This was really a tremendous test of my patience, accuracy and determination. I've never freehanded something this precise. One slip of the router could mean starting all over on a new piece of maple. But that fortunately didn't happen because I moved super slowly and did a shallow pass first, then went all over again but deeper to 3mm depth. This job took me half a day, but eventually I was really happy with the result. But for all of you, please, choose your band logos to be simple, like 9-inch nails for example. And as if this wasn't difficult for me enough, the customer asked me if I could make the logo and the side dots light up with LEDs, to which I courageously answered no. But after feeling like this and dealing with a huge hit to my craftsman ego, I was wondering about the possible options and eventually got an idea of a practical solution which wouldn't cause neck instability or compromise sustain. And in case of any problems, it also has to be repairable. I turned the fretboard upside down and routed a channel which will serve as a passage for LED strips. But the hollow areas of the top dots and the band logo were filled with pure epoxy, which will diffuse the light and reinforce the fretboard, especially in the logo area. Now you hopefully understand why I covered the truss rod with the thin piece of maple. It's because 50% of the fretboard is hollow, so the LED strips can go through. And by setting the neck tension, the truss rod will only be pushing against the maple strip. If you don't know how the truss rod and neck tension works, just know that what I did is clever. This is the shape of the 2mm deep channel underneath the fretboard, which is now ready to be glued to the neck blank.
So let's see how it shines. Yep.
I always want my fret tanks to be invisible, so I went back to my Dremel holder and slid it against the straight edge, which has roughly the same radius at the bottom as the fretboard. This is also precise and tedious work, but I've done it like this many times already. I shaped the neck into C-profile, and this is the final cross-section around the middle of the neck. You can pause the video if you want to study what all is inside, but I think it should be clear that there's the maple strip which separates the hollow channel from the truss rod. And if it isn't obvious, I should say that having an LED fretboard just comes at the expense of a thicker neck. I had to leave more mass of wood on the neck because of the stability. I measured the neck and it should definitely join the body positivity movement. I milled the edge body wings like this for the neck blank to only be visible in the back, and so it looks as a solid piece of wood from the front. A tip for you: never buy a cheap double-sided tape.
Art.
After I glued the body wings, I started carving the body to have some visually interesting 3D curves. So I created various inclined templates for my router to remove the bulk of the material, and then used a chisel and a rasp to smooth things out. I like when the design is composed of curves and waves which flow into each other. I don't know how to describe it, I just go by feeling most of the time. I had to make the control cavity extra spacious, because, as you will later see, I had to fit almost the whole computer in there. I put together this simple fret press clamp which made my life a bit easier. I put few drops of CA glue on the fretwire and then clamp it down. It's just a simple radiused and notched piece of plywood screwed to the clamp, and it works just fine. When I was done with the fretwork, I shielded the cavities and I sanded the whole base and dyed with Rubio Monocoat's Intense Black, and I dyed black the whole instrument. I've tested many types of hand-rubbed stains and dyes, but nothing really compares to Rubio's Intense Black. It offers the best coverage and uniformity. And because you can't really put anything else over the precolor from Rubio than an oil from Rubio, and I've unfortunately tested that, it happened to be exactly what I used eventually as a clear coat finish. But it is so expensive. This little bottle of oil, which comes with an accelerator, costed $36, and then you'll end up with a great and resistant finish. But it's matte, and I wanted to have something kind of satin finish, so guess what? Rubio sells separately a sheen boosting product, which is another $45. And it looks significantly better after the application, but in Rubio, they certainly know how to do business. I still prefer hand-rubbed finishes because so far it's the only thing I can do well. I've also wanted to try something new this time, and that's a ceramic coating, which is meant for cars, but it should also work over most of the wood finishes, including Rubio. It was another $45, and I've noticed a small difference in overall sheen and contrast. This is the before and after photo. You can be the judge and tell me if it's a $45 difference, but it should also buff the protection a bit. I've spent $125 just for the finish of this base, which is crazy. It's the equivalent of 45 pounds of chicken breasts in where I live. That's almost 2 months of protein supply for me. The finish of this base is best described as satin, half sheen, semi-gloss, mid-glow, silky partial shine. But now it's time for all the hardware assembly, and I started with the LED system. I've made two, let's say, modules of LED strips attached to aluminum sheets, one long and narrow with just a single strip, and a second, which I'm showing here, wider with 1.5 rows of LED strip. It was tricky to find the exact specific type. I needed the strip to be 5 volts, COB, which gives homogeneous seamless beam of light. It had to be only 8 mm wide, dimmable and blue. After days of unsuccessful searching for a national dealership, I ordered this strip from Amazon. Here you can see me plug in the PWM regulator, which will serve as a turn-on switch and as a dimmer for the LEDs. This is a basic EQ which you can use to cut or boost the treble, bass and mids. It also has the mid-range selection. And I'm connecting the EQ with separate volumes for the neck pickup and the bridge pickup. Originally, I was supposed to fit this huge 12V battery in the control cavity and have it power 5 rows of 12V strips. But it would be generating so much heat, it would be unacceptable. And the battery was also too big to fit in the control cavity, and other downsides like being a no-name brand with 0 reviews and the weight. But it also was just a rechargeable battery on its own without any protective battery management system. So that's where I got the brilliant idea to just put a whole power bank in there. And it's got all the benefits. It's smaller, does 5 volts, has all the BMS, has positive reviews, the capacity is 2 times longer, and it turns on the moment it detects any output. The point is to have the LED fretboard rechargeable, so this is the final circuit. USB-C socket connected to the power bank, which has a USB-A output composed of simple hot and ground wire, PWM regulator, and finally the LED strips. That's all. But there was just one more obstacle. I've unintentionally created my first analog synthesizer. The amp was somehow catching the PWM regulator frequency when I turned on the fretboard and caused this insufferable buzzing. But luckily, after some studying, I found that I only need to switch the PWM to a stronger one with higher frequency, which can't be heard even if amplified. It was such a relief that after all the work, everything was working just fine. As I said in the intro, everything about the rechargeable LED band logo fretboard inlay is experimental. But I was trying my best to research every component in the circuit and combine that with my experience to make hopefully a sustainable and functional instrument with this cool feature. If you've learned anything new, or at least you find my work entertaining to watch, please consider subscribing. I'm planning on doing more of these extraordinary instrument builds, and your support means a lot to me. Also, if you have any question about this build, you can leave a comment or text me directly on Instagram. The only thing left to do was the nut, and I wanted to make it from stainless steel for it to be virtually lifetime lasting without the need for future replacement. I was afraid that I would lack the proper tools to mill the slots, but eventually these carbide Dremel bits cut through the steel like through butter. Luckily I possessed all the necessary widths of these bits for everything to be sitting there not too tight and not too loose. After shaping and sanding the nut, I wanted to turn it black chemically with a gun blue, but this didn't work at all. I suppose it's called stainless steel because it cannot be stained with some $5 gun blue acid. So I went the classic way of spraying. This coating seems to hold on quite well. Please keep in mind that I've only recorded and shown about 80% of the process, so if you feel like I skipped some steps, it's just because I wanted to record and explain the most relevant and interesting points for the sake of brevity. In the end, I did some basic setup and the base was done.
Co není to těžký.
Ty, no bolí kolem.